Let's go to the first theorem. Okay, it says theorem 10 in the textbook, but this is going to be our first theorem. Theorem 1. Theorem 1 reads: a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angles to the chord. A straight line drawn from the center of a circle. Center of a circle is always symbolized by a letter O. So this O shows that is the center of a circle. You see the straight line OM drawn. A straight line drawn from the center of a circle to bisect a chord. This is a chord, right? Bisect means divide into equal parts. Okay, which is not a diameter, it's at right angles to the chord. Okay. Example 1. A chord of a circle is 12 centimeters long. A chord of a circle is 12 centimeters long. The radius of the circle is 10 centimeters. Calculate the distance of the midpoint. Calculate the distance of the midpoint of the chord from the center of the circle. So we see the chord, the circle. This is the chord called AB. It is told we are told that it's 12 centimeters. So given the first theorem, which says a straight line from the center O of a circle bisects the chord. To bisect is to divide something into equal halves. So 12 centimeter length of chord that becomes 6, 6. If you look at the various now, 6, 6. Okay. So we're basically looking for line OM, distance OM. Okay, so you must know that since the theorem says a straight line is at right angles to the chord, okay, so the straight line from the center is at right angles to the chord. That means it forms 90 degrees. So anytime you have a right angle triangle, that's a right angle triangle with 90 degrees. See this small box? You can always apply Pythagoras. So to get the distance, OM, we apply Pythagoras. So this is our hypotenuse. Remember, this is just, look at it. You see the right angle triangle that I'm tracing out? Okay, so that is the hypotenuse is 10 centimeters. Get it closer, 10 centimeters, 6 here. So to get OM, just do a Pythagoras says, that's Pythagoras theorem. So OM, that's or MO squared, just subtract square of the hypotenuse, that's AO squared minus AM squared. 10 squared minus 6 squared to give us the side MO, which is the distance from center of a circle to the chord. So do that, 10 squared minus 6 squared is going to give us 100 minus 36. 100 minus 36 is 64. So the square root of that, because the Pythagoras is square. So to remove this square sign, just find the square root of 64. And you have MO is equal to 8 centimeters. So the midpoint of the chord is 8 centimeters from the center of the circle. So that answers the question. Calculate the distance of the midpoint of the chord from the center of the circle. Is that clear, guys? Question 6 says an isosceles triangle ABC has its vertices on a circle. If AB is equal to 13 centimeters, BC is equal to 30 centimeters, and AC is equal to 10 centimeters, calculate A, the height BM of the triangle, B, the radius of the circle to the nearest whole centimeters. The diagram for that question is something like this, okay? We're told that AB is 13 centimeters, BC is 13 centimeters, and AC is 10 centimeters. So if you look at this very well, see O is the center O, and we have the radius R. So this diagram is very important. It's very important you draw diagrams in geometry. Circle theorems is part of geometry. So diagrams help you to understand and solve questions easily. So you can visualize. Okay. So you have the diagram there, and so if you flip it, if you spin it, you see it looks something like this without the circle. So you have that center O, and you have radius. Remember, radius is the distance from the center of a circle to the circumference. Okay, so that's why I have R all over the place. Okay, so 13, and 10. 10 has been split into, bisected into 5, 5. So that's diagram and that diagram there. We are told to find A, the height BM of the triangle. The height BM of the triangle. From the first diagram, look at it, BM. Remember, M is the midpoint of the chord AC. So to find height BM, so it helps you to just isolate, bring out only the triangle. So you have the triangle, so I can see it very well here. So you have 13, so it looks like an isosceles triangle. 5, 5 because I've been split by the line from the center using our theorem. Okay, so bring out the triangle, you have a right angle triangle, then you can apply Pythagoras to find BM.